Hello and welcome to Startup Hack. Today we are going to talk about async and await in .NET every developer should know about. So let's jump right in. Make sure to check out the link down below because we always provide code samples that you can pull down and follow along so you can see in our project.
Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started.
Alright, as developers, we often encounter situations where we need to perform tasks concurrently to ensure our applications run efficiently. The asynchronous programming model in .NET brings us the powerful trio task, async, and await. In this video, we will unravel the mysteries behind these concepts and explore how they enable parallel execution, providing a clear understanding of how they work together. So, unraveling the essence of tasks. Before we embark on our journey into the intricacies of async and await, let's take a moment to fathom the core of the task class. People tend to believe that a task isn't merely a conduct for thread initiation or guaranteed ticket to parallel execution. Are they right? Take a look at the following snippet. Is it necessary asynchronous method, or rather we should think of it as a maybe asynchronous method? If it is cached, it will return the result right away, won't await anything. Tasks should be thought of as a data structure representing an execution state and outcome which encapsulate the essence of both synchronous and asynchronous execution. Consider a scenario akin to ordering a tool online. Imagine you urgently need a screwdriver for a quick fix. You place an order, eagerly await its delivery, and upon receipt complete your task. Later, when you need the same screwdriver again, you don't have to reorder and await its delivery anew. Instead, you retrieve it promptly from your toolbox. Similarly, a task might represent an already completed operation that can be instantly accessed, bypassing the need for further asynchronous orchestration. Okay, now navigating the async await symphony. Having unearthed the true essence of tasks, let's now immerse ourselves in the harmonious duet of async and await. Take a look at this example. This is the same method we implemented earlier but with enhanced readability. As previously mentioned, this method might execute on the caller's thread if the data is cached. Alternatively, in the scenario of fetching data from getByte array async, the method may progress up to that point and then pause, setting the thread free while awaiting the signal of the IO completion port. Once the signal is received, the subsequent code will be scheduled for execution on a thread pool thread in default. Async doesn't inherently perform complex actions, rather it serves as a marker capturing our attention and indicating that this method could potentially await a future result or it might not. Await signifies the juncture in the code where the possibility of producing a future result emerges. Unlike the task class, which is a component library essential a type, async and await are distinctive compiler features. The compiler will break the method at each await point and generate optimized code that appropriately schedules the code following the await or keep it on the calling thread if it is an already completed task, like in the case of a cache result. Alright, test yourself. Let's enhance our comprehension by exploring a few simplistic, though not necessarily practical code snippets. Nothing extraordinary unfolds here. This code operates synchronously, causing it to block the caller thread. This is how the code might appear without utilizing the async feature. Let's now example the following snippet. Similar to the previous example, but without the second block. In this case, the compiler-generated code demonstrates its intelligence by inspecting the status of the task and recognizing it that is already in a completed state. Consequently, it refrains from scheduling the execution and maintains the continuity of the operation on the calling thread. The final sample sets itself apart in the following manner. The task.delay returns a task that transitions into a completed state and 2 seconds into the future. Consequently, for these 2 seconds, no thread becomes associated with the method. Subsequently, as the task enters its completion state, the remaining code is scheduled for execution on a thread pool thread unless operating within a non-default task scheduled context. So thank you for watching this video. I hope you learned the concept of async and await in .NET. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.